So this is module 2, equations of motions. Let's look into it and see unsay atong ma-learn ani. So in 4th BC, kani siya ang mga belief sa una na yung na heavier objects would fall faster than lighter ones. This is allegedly ingon si Aristotle. So kung nakay elepante, like this one, let's see. An elephant and a feather, kung imo siyang i-release, mao na gyud ang elefante kay mas bugat man siya. And if you do an experiment, like you don't need an elephant, pwede ka heavier na object, like a block, piece of paper or a block of wood or a rock, mao na gyud hugid ang rock. Okay? So, in 19 centuries later, here comes this guy, Galileo Galilei, in 1564. He did some experiments at Tower of Pisa using some identical shape na material. Identical shape na material, but lahi na composition. So, like for example, this one, these are both spheres, identical shape, but they have different mass. So, to indicate na like silag mass, I changed the size basically. But if you have the same na size, let's say one is a sphere made of let's say metal, and the other one is a sphere made of wood. If pag drop niya, they notice na they fall roughly at the same rate. So what is the explanation here? So ang explanation would be that there is something nagaprevent sa iya, which we call as air resistance. So in 1643, this guy, Sir Isaac Newton, thought about the concept what is holding the body in particular position. So this concept is what we call gravity. And there was this legend na ang discovery sa gravity kay nagtambay daw siya sa ilalom sa apple tree o nahugan siya apple, and he had this what we call eureka moment or realization the existence of gravity. So gravity is the concept of gravity is quite important because it affects di lang ang apple sa tree paghulog niya, its attraction towards the earth, but also planetary na level, like ang nganong ang moon na siya dira ang position, why the tides changes or so on. So this is quite an important discovery in this century. Okay. Kinematics comes from a Greek word meaning motion. It's a study of motion and its causes. So there are three quantities that describe motion: ang time, displacement, and velocity. So notice that displacement is a vector quantity and velocity is a vector quantity. Time diri is a scalar quantity. That's what we've learned earlier sa previous na module. So time, as we know, it describes how long an event happens. Okay, time is measured in terms of change. Ang typical na symbol niya would be t, and it is a scalar quantity. So di magmatter kung seconds, minutes, hours, days, or centuries, but as long as it's a parameter sa time. Then we have distance and displacement. So earlier we know that distance is a scalar quantity while displacement is a vector quantity. Okay. So symbol niya is of course can be written simply as x or y for the distance. Ang displacement can be capital, but rather bold x and y, or di siya bold but na siya arrowhead. Okay, so that's the difference. As we said earlier, simply means ang displacement is like the distance, they're both magnitude, pero ang displacement may iya direction. Okay, so for example, this one kani siya nga path kaning by this color, kani siya kaning purple ba ni, is what we call the distance. The displacement is from point A to point B can be represented by this one, simply ang direct niya na path. So if you're traveling from this place A, Iligan, towards Cagayan, ang distance niya if agion sa dalan would be 269 kilometers kanang sa kuan. Kanang dalan gud mismo na concrete or pathway sa kanang mga sakyanan. But if you go by from point A to point B directly, it's just around 35 kilometers kung na siya straight nga dalan from A to B. Okay? Next is ang speed and velocity. So again, the difference is one is a scalar quantity, scalar. The other one is a vector quantity, ang imong velocity. An expression for that one because it's given by the distance over time. Distance over time is basically the change in distance. It's a rate basically. And you have the displacement over time for the velocity. Okay? I think redundant na ni siya kung putang pag-direction kay ang displacement na iyan na sa direction daan. Okay? So important is that the velocity is magnitude with direction. Okay? Okay. So here we have an example of an object moving in a straight path. So it's a car. Start siya at x naught. So x naught, ang 0 here or O na subscript, it's called a naught, meaning starting niya og ang xf or ang x final. So it has moved from x naught to xf. So it started from t naught to t final. So let's say, so this one can be a magnitude. Okay, wala man gibutan direct arrow, right? Wala man gibutan direct arrow, so it can be like that. So erase that a bit. Apologies. So let's say this is a speed. So the speed is the change in the distance x naught and xf. So xf minus x naught. O ang time niya is t final minus t naught. So this would be the speed. If tagani mo, if you change this to velocity, so let's say this is moving in the negative x-axis. So we can put an arrow here and butang natog negative I hat. Okay? That would suffice as a direction. Okay? If you remember, unit vector ni siya that is specific to a particular axis, ang I hat meaning sa x-axis. Negative siya kaya it's going in the negative way. Okay? So here's an example. So find the average speed. So it's a scalar quantity in meter per second, and the average velocity of a car if it takes, so velocity is a vector quantity, if it takes 5 minutes to cover 20 kilometers going towards the west. Okay, so the average velocity is simply the change in the distance over the change in time. Okay, so that means V average, ang XF nimo is, what is XF nimo, huh? XF nimo is 20 kilometers, and let's say nag-start siya but some origin, so 0, 0. Or just simply 0, kaya isa raman siya ka-axis. Okay, so nag-start siya from 0 time to 5 minutes. So 20 divided by 5 gives you 4. So this is 4 kilometers per minute. So if you do the math of that one, it will give you a value of 66.67 meter per seconds. Okay, if you convert that one to meter per seconds. Next is that this one is the average speed the velocity is simply using the same magnitude here, pero butang na to direction westward. Or this is also equal to negative I hat if you want. Okay. But for this case, it's west ang gihatag na direction. Okay. So I hope you learned something. Next one is an acceleration. So acceleration is a vector quantity which describes the change in velocity within a time interval. Okay? Ang unit niya, class, is meter per second squared. Meter per second squared. Okay? So ang formula niya is normally A, or if you want to be specific, siya arrow on top. Okay? So the formula is the change in velocity over the change in time. So if the value of A, acceleration, is positive, meaning the body is speeding up, because for this one to be positive, ang V final should be greater than the V initial or V naught. Okay. If A is negative, the body is slowing down because ang V final ni Moha should be less than V naught. So pahinay na siya. V naught. So if the object moves at constant velocity, then the acceleration is zero because ang imong V final is equal to the V initial. So not necessarily at rest siya. It can also be at rest, pero it can also be constant lang iyang dagan, ang iyang velocity. Okay. So let's derive an equation, the first equation of motion, using ang acceleration. So the acceleration, if you remember, is the change in velocity over change in time. So rewriting that one, you have this function, and it's say nag-start siya at an initial of 0, meaning starting point is 0. So you have this one 0 here, mag-cancel, wala na siya. And we can bring this one to here, so it becomes an 80, and this becomes V minus V naught. Rearranging by transposing the negative V naught here gives you this equation that the velocity final, or any velocity, is equal to V naught plus AT. Okay. We can also derive the second equation sa equation of motion. So from the velocity, we can derive the displacement simply by displacement is velocity times time. Okay. If you remember, ang velocity ni mo na siya unit na meter per second. So you multiply that one by unit na second, this cancels out and gives you a unit of displacement. Okay. So if the velocity is not constant, then we can use the average velocity. What is the average velocity? This is the average velocity. V plus V naught divided by 2. Basically just an average. So, okay. So delta x is equal to, from this function, displacement, delta x is equal to velocity, but this is average velocity, so V plus V naught divided by 2 times the time na parameter. Okay? And once you have that one, we can substitute ang kaniyang V with this first equation na V from the first equation. So when you substitute that one, you have this function here. So this becomes V naught plus AT plus V naught divided by 2. Pag imo nang i-combine, ang imong V naught here, mag-combine with this V naught, so it becomes 2 V naught over 2. 2 V naught plus 80 over 2 times time. So expanding ang delta x ni mo, which is just x minus x naught, you can have this function here. Okay? So this becomes 1/2 80 squared. Kani siya. This one here. O kani siya, 2V naught divided by 2V naught times t. Transposing mo divided by 2, you get V naught t. So this one is the second equation. I hope it's clear to you. Now let's derive the third equation. So we recall ang expression na delta x time is equal to the average na velocity, so v plus v naught divided by 2 times t. And the first equation na kani siya, which we used earlier, which we can rearrange the expression of this one to this. Okay, so what do you do? So v transpose nimo da siya sa picas, it becomes a negative v naught, and you divide it by the acceleration. So you have these equations here. Now, going back sa kanina expression, delta x is equal to v naught plus v plus v naught over 2 times time, pero ang time nimo is kani siya, substitute nimo siya dire, and you get this expression here. So v plus v naught times v minus v naught will become v naught v squared or minus v naught squared, and ang denominator nimo simply 2a. So we can rewrite this one by expanding this one to x minus x naught. Then you multiply by 2a. Okay, so you have this expression. This is now the third equation, the equation of motions. So let's look at that one in summary. So summary, we have the following equation. V is equal to v naught x minus x naught is equal to 1/2 v plus v naught t. So this another equation here, which is also an expression of equations of motion. And lastly, this one. So look at the first equation. The first equation, you have the following na mga parameters or physical quantities. Ang v naught, on acceleration and time. So it has these parameters here. Pero wala siya x o x naught. Okay? The next equation, na siya x o x naught. However, wala siya acceleration. So it's basically all except of the acceleration. Except acceleration, yeah. Then you have the third equation, which natanan except sa imuhang v final. Wala siya. Okay? And the last equation, na siya tanan except wala siya time parameter. So this is quite useful na equations na inyong i-familiarize. So we've derived it, and now you can familiarize it and use it depende sa given a problem. Okay, so we simply here, if you want, because this one is along the basically horizontal na motion, if you want the vertical na motion, ang acceleration is replaced by g. Okay, so vertical na siya. Ang g here refers to gravitational acceleration. Okay. So, substituting, you have the equations of motion along the y-axis or the vertical motion. So, g na siya tanan. Here. And ang imuhang x has now become y's. Okay, y's na siya. Okay. So, the acceleration g, kung kani siya nga type na expression, is given as negative 9.8. Okay. Sa uban books, ang g nila is positive 9.8, pero ang ila, the equations nila, this is not positive, but rather negatives. Negatives. Kung ila g is positive 9.8. But for our case, we're using g is equal to negative 9.8. Okay. Yeah, and that's it. I hope you learned something new today, and I hope you enjoyed it as much as I did. O kung na mo yung pangutana, you can ask your professor. If not, you can also email me And that's it. Ingat and God bless.